Hello and welcome to the section 1.2 lecture. Today we're talking about adding integers with different signs. The last time that we met we talked about adding integers with the same sign where they were both either positive numbers or negative numbers. Today we're going to mix those up a little bit. So let's get right into it and see what we're doing. For the first little bit we're going to be working with a number line. And so last time we talked about a problem like 3 plus 2, those are both positive numbers, and we can think about starting at 3 and moving 2 in the positive direction, okay, which would be 2 units to the right. That's going to end us at 5. If I instead want to try 3 plus negative 2, then I'm going to start at 3 and I'm going to move 2 units in the negative direction. All right, so moving 2 units in the negative direction is going to bring me to positive 1. Let's try that on a couple other problems. We're going to try that same process of starting at the first number and moving the second number along the number line. So on this one I'm going to start at 4 and I'm going to move 3 units to the left, which is the negative direction. 1, 2, 3. That ends me at positive 1. So my answer for 4 plus negative 3 is positive 1. Okay. If I want to look at negative 7 plus 5, I would do the same thing as I did before. I would start at negative 7, and I would move 5 units. Since positives are to the right, I'm going to move to the right 5 units, which is the positive direction. So I'm going to start at negative 7, move 5 units to the right, 3, 4, 5, and I end at negative 2. So my answer would be negative 2. And then if I look at 6 plus negative 6, I'm going to start at positive 6. I could write positive 6 there. And then I'm going to move 6 directions, or 6 units to the left, which is the negative direction. So if I start at 6 and move 6 units, 4, 5, 6, I'm going to end up at 0. Okay. Make a prediction. Predict the sum of negative 2 plus 2. And explain your prediction. I'm not going to make a prediction, so to speak. I'm going to work through it. Hopefully you can make a prediction. But what we're going to do is we're going to start at negative 2. Start at negative 2. And move 2 units in the positive direction. And that's going to end us at 0. So 0, we start at negative 2 and move 2 units right. Brings us to 0. Alright, now we're going to go over something that would probably be a little bit easier to do in class because we would have access to these counters. I'm going to show you a different way that's a little bit easier, something that you could probably do like using a piece of paper and a pencil rather than having to have manipulatives. So we'll look at it how they show it with the yellow and red counters, but most of the time we're just going to be dealing with plus signs and minus signs. Okay, so this is a great way to look at it because if you're unsure about what to do, this can give you a good place to start. So what we're going to look at is we're going to model 3 plus negative 2, and most of that's actually done for us here. We're going to start with 3 positive counters to represent 3. I'm going to use plus signs for those. They use the yellow counters. We're going to be using plus signs. And then we want to add negative 2 counters, so, add 2 negative counters, should say that the right way. We're going to use minus signs for that. They use positives, or they use red counters, sorry. So we're going to put those 2 negative counters in there with the positive ones. And then we want to do what's called forming zero pairs. So zero pairs are what we see right here when we pair up the one positive with one negative. And those will actually cancel each other out. Because if you just look at 1 plus negative 1, you start at 1 and move 1 to the left, takes you to 0. So both of these are going to take us to 0. And so what do you have left when you remove those, when you pair those off? You have one positive counter left. And so what that means is 3 plus negative 2, which we did on the previous page, is 1. And now I want to do the same idea, but they don't give it to me. I have to actually do it to model negative 6 plus 3. So I'm going to start with 6 negative counters. For that, I'll use minus signs. 1, 2, 3, 4, 5, 6. And that's representing the value of negative 6. I want to add in 3 positive counters right down below it. So positive, positive, positive. That represents adding 3, or positive 3. And then we want to form our zero pairs. There's a pair. There's a pair. And there's a pair. And all these are 0. And so what do we have left when we get rid of those 0 pairs? We have 1, 2, 3 negative counters. So the sum negative 6 plus 3 is going to leave us with an answer of negative 3. All right, so now for a really important step, a really big kind of key piece that's going to help you find answers to a lot of other problems. We're given this scenario where Kyle models the sum of 2 integers, and they're positives and negatives. He uses more negative counters, or red counters that they used in the picture. I used minus signs. So he uses more minus signs than positive signs. What do you predict about the sign of the sum? So is the value going to be, when we find our answers, our value going to be positive or negative? And they want us to explain that. So go ahead and think about that for a second. So if we have any amount, it doesn't matter the actual numbers, but let's say I've got some minuses and then some pluses to match up with those. And in this scenario, I have more negatives than positives. I don't even know the numbers. I wasn't worried about how many. There could have been any number here. But as long as there's more negatives than positives, the sign of the sum, the answer, is going to be a negative. And I'm going to leave it to you to fill that in, but it's somehow related to the fact that when we form 0 pairs, we're still going to have negatives left over. I'll kind of clue you into that. Say, like, we'll still have negatives left over. Okay. So, you'll want to write something a little bit more elaborate than that, a little bit more meat to that statement, but that's kind of the punchline, is that when I'm done, I'm going to form up my 0 pairs, and I'm still going to have negatives left over. Okay. I'm going to take a quick pause here in the Google form that I'm going to have you fill out for this, there's going to be a question that's just asking for the code word, just to make sure that you're actually listening to the video. I'm not going to write it down because then that would defeat the purpose of listening to the video. But the code word for today's lesson is banana. The code word for today's lesson is banana. So make sure that you get that down. Maybe write that right here. Say, code word. And you can write in banana. All right, let's get back to it. Let's practice a couple of these, and we can use the counters. I like using the counters. It's a good way to visualize it, because I really like the fact that it's really symbolizing I'm putting these two numbers together. That's what I think of whenever I think about addition. I have these two numbers, like in number 3 here, one's a 5 and one's a -1, and I'm going to put those together, and what do I get? So if I visualize that, I have 5 and I have -1. I'm going to form my 0 pairs. I only get one of those, and what am I left over? I have 4 positives left over. Okay, for number 4, I have 4 positive counters, and I have 6 negative counters. All of these will give me 0 pairs. Okay, and I'm left with two negative counters left over. If I think of 1 plus -7, I have a single positive counter, and there's no reason why. Notice that we always kind of align it to the right. There's no reason to do that other than that's what they did once. So this time I'm going to align them on the left. So I have 7 negative counters. 1, 2, 3, 4, 5, 6, 7. And the main thing to think about here is that when I form 0 pairs, I get one of them, and I'm left with 1, 2, 3, 4, 5, and 6. Since they were negative counters, I get -6. Last one we have here is 3 positives and 4 negatives. I get my 0 pairs from all these that were paired up, and I have 1 negative counter left over. Okay. So now for some kind of, anytime you see things like in boxes like this, it's going to be somewhat important to, it's kind of a key concept. It's a way to, if we're actually taking notes in class, like on notebook paper, this would probably be something that I would want to have on there. If I was maybe filling out a note card for a test or something, I would probably have something related to this on there. All right, so this is sort of summarizing the last 2 sections that we've gone over. The first one is talking about same sign. So this is what we talked about last time in class. It says we add the absolute value of the integers and use the common sign for the sum. So the answer is going to have the sign that the 2 numbers that we added together had. And you can see that in these 2 examples. So 3 and 5 are both positive, so my answer is positive. 2 and 7 are both negative, so my answer is negative. For same signs, we noted that we want to keep the sign. And I said that last time in class. That same sign, keep the sign. Okay? For different signs, we want to subtract so they use some kind of complicated words to say this. I really want to think about going the big number minus the little number. And we haven't really done it that way, but that's another strategy that you can do. Technically, we did this when we used the counters. We used some subtraction ideas here. but we want to go the big number minus the little number, and we want to keep the sign of the larger, or I'm going to say of the big number. So we can see that here 5 is a bigger number than 3. 5 minus 3 is 2. Since 5 was negative, my answer is negative. Same thing here, 10 is bigger than 1. 10 minus 1 is 9. Since 10 was negative, my answer is negative. And then the last one they talk about is a number and its opposite. And the sum is always 0. So 5 plus negative 5 is going to give me 0. 6,200 plus negative 6,200 is going to be 0. Anytime you have a number and its opposite. Let's look at that with this example. So here they actually do take the absolute values, but you don't have to think about absolute value all the time. What I do when I look at a problem like this is I'm just thinking 11 minus 6. I know that that's 5. And since 11 was bigger and it's negative, I'm going to use a negative for my answer. So I'll get negative 5 as an answer, just like they do. Okay. Part B here is just a number and its opposite, 37 and negative 37. And this really, goes to my idea of putting these two numbers together and seeing what you get. Okay? Let's finish off with these your turn problems. All right. So we have, we start off with kind of a doozy here. We have negative 51 and positive 23. Visualize this how you want to. I'm going to subtract them, which isn't going to end up as the easiest thing to do, but I'm going to subtract them. And remember our subtraction rules. I have to borrow 1 here. That makes that an 11. 11 minus 3 is 8. 4 minus 2 is 2. So I get 28, and I take the sign from the larger number, which is negative. 10 plus negative 18, I'm going to think about 18 minus 10, which is 8. 18 is the larger number, and it's negative, so my answer is negative 8. 13 and negative 13 are opposites. I get to go right to 0. And lastly here I have negative 26 and 25. 26 minus 25 is 1. Since the 26 was bigger and it was negative, my answer is negative. Okay? So hopefully that made sense. Hopefully that helped you kind of iron out some of the details. If you have any questions, be sure to write them down. And have a good day. We will see you in class.